So good afternoon, everyone. My name is Dave Cuthbert. I'm a solutions architect with AWS supporting our US federal civilian practice. I know it's the last talk on what's probably been a very jam-packed day, so we'll probably run out of time. I have a lot of material to cover. Probably won't have time for questions on stage, but I'll be more than happy to answer any questions you have afterwards, just down here. Come find me. And so this talk, Demystifying Storage on AWS, is intended to give you tools to optimize how you architect your storage solutions in the cloud. So the first problem that we typically see for that IT departments have is that they get somewhat ambiguous end user requirements. So your users may come up to you and say, "Oh, my application will need 15 terabytes." Well, on the face of it, that sounds reasonable, but if you start to dig into it, what does that actually mean? Does that mean 15 terabytes from day one? Does that mean they never think they'll exceed 15 terabytes ever? Does this need to be super fast storage? Is hard drives okay? Do we need to go with SSDs? Do we need to do some kind of RAID solution to get the performance they need? A lot that we haven't quite answered here. And this tends to be one of the more ideal specs that I would hear from a user. Sometimes it's more ambiguous that, oh, no, we need enough storage to support 300,000 users. Well, that's I often have a hard time trying to figure out exactly what does that mean. Because if it's 300,000 users just accessing a static website, they're not storing any data, it doesn't matter how much storage I provision. It's just enough storage to serve my website. On the other hand, if I have research scientists all trying to store their data, that's going to be potentially terabytes of data times 300,000. And are they all coming at once? Is this going to be spread out throughout a year? So a lot of questions that we can't quite answer. And then finally, of course, nobody comes up and says, "Oh, give me the slowest storage possible." No, I've never heard that requirement. Would love to hear that someday. But everyone wants storage to be fast. Sometimes they want it to be cheap and they're willing to forego fast, but I've, again, never heard that somebody wants it to be slow. Even when we say, oh, it needs to be fast, maybe it's doing a database, there are different dimensions of fast. Do we need throughput? In other words, can we parallelize these disks, these spindles if we're doing hard drives, SSD drives, more likely today? Or do we need low latency, something that's going to return the same data over and over very quickly? So there's a lot of questions here, and often you're kind of struggling to come up with an answer. And how you end up buying? Well, okay, given all this ambiguity, if it's a mission critical workload, something that if it fails, at best, okay, we might have egg on our faces, we might get fired. At worst, it could, especially if you're an agency, if you're a nonprofit dealing with the human factor here, it could bring harm to your end users here, to the end customers that you are trying to deliver for. So what you do is you provision this like crazy. You probably overbuy, and you watch it very carefully to make sure that this thing does not go down. I make sure everything is operating in a nice, comfortable range here. A lot of inefficiency here, but boy, I do not want this to fail. And then there's everything else. Oops. Apologies there. Don't hit that button. So then there's everything else. So everyone else who isn't lumped in this mission critical space here, they are on what's probably an oversubscribed platform. Some folks happen on very lightly loaded spindles. Others may be just going at it quite a bit. And it's not the greatest user experience, but I am cost optimizing here. I'm trying to make sure that I am meeting my budget requirement. But the worst part about all of this is that typically, if I'm managing physical hardware here, there's nothing I can do. I can't go out to my procurement folks and say, hey, get me 6 more racks, and I'm going to go ahead and install them by 4:30 today. No, it's just not an option. These typical cycles are long. You're lucky if you can get it within a month. A quarter is more likely. If you're on the federal side, you're talking about trying to get a big allocation next October. So quite often there's a delay between when you identify this problem and when you can fix it. And boy, wouldn't it be nice if we could just purchase all of what we need just in time. Unfortunately, in the cloud, that starts becoming a reality. So what I'm going to talk about is kind of the go-to solution that if you can't solve it anywhere else, you can always do it here in the cloud here using what we call our elastic block service, block storage service here. So let's take our traditional server that we have on premises. It has some CPU and memory, and then some storage associated with it. And here I'll say that I have 200 gigabytes of storage, doubled because I want to make sure that if one drive fails, I don't lose all of my data. So I have that in a RAID 1 configuration. What does this look like on AWS? Well, with our Elastic Compute Cloud, EC2, I go ahead, provision the instance. That gives me the CPU and RAM. I can go select the type that I want there. But then the storage, I get to provision separately. If it's small, I can go down as little as 1 gigabyte. I can go up to 16 terabytes. In this case, I will go ahead and tell it, okay, we had SSDs on-prem. I'll go ahead and provision a 200 gigabyte SSD volume here on EBS. Now you'll note that there's this additional thing here, GP2. That's a general purpose volume here. It's our 2nd generation. It means that we're not doing anything special to try to optimize the I/O here. This is my go-to solution 99% of the time. This is all that we typically need, and we never need to do any more optimization from here. You get 3 IOPS per gigabyte here. So for this volume, I would have 600 IOPS. IOPS are input-output operations per second. So you get 3 IOPS per gig as a baseline, plus a burst capability. So if you have a burst of reads, you can go ahead and serve that. So far, all we've done is just kind of replicated what we have on-prem in the cloud. What happens if this application is wildly successful? 200 gigabytes, not going to be enough storage here. So, again, on-prem, I would kind of be stuck. I'd have to either find a new server or de-rack it, open it up, change it. With EBS, I can actually go in and say, go ahead, double this out to 400 gigabytes now. And now, let's say that if I'm operating on Linux, you can go ahead, resize the file system online. Just by doubling the storage, that doesn't mean your file system is necessarily going to pick it up right away. You have to run a tool. Nowadays, with modern file systems, both Linux and Windows, you can do this online without taking any downtime. And go ahead and start using that storage. And again, because we've doubled the storage now, I also have doubled my I/O capability. And I can keep going here. Let's say we double again, 800 gigabytes. And we can go all the way up to 16 terabytes per volume. You can always do multiple volumes here, but let's say that for now, we're just looking at one volume here. This solution, if you want to run it in our US East region, either Virginia or Ohio, one of those 2 regions, it is 10 cents. Currently, the prices are 10 cents per gigabyte per month. So you'd be looking at $80 here for this volume here. Now, maybe as I get some experience running this application, I noticed something interesting, that I never really accessed much data beyond what was just put in there in the last day. This is a very common model, that the newest data, that's the freshest data, that's what everyone wants to see. That's what everyone is always querying and so forth. And now I've been tasked to go ahead and double my storage capability again. But now with this additional information, okay, I know that the data that was put there in the last day, most of the reads happen there. I have some business intelligence reports that run daily, weekly, and that goes against the last few months. And then the rest of the data, it's hardly ever touched, never touched. I can't delete it because maybe I need to keep it around for auditability. So I can't just go ahead and wipe it out, but I don't want to really pay a lot for that storage. So let's say we're going to go ahead, double this again. The first thing I'm going to do is provision a different type of volume here for all of that cold data that we never touch. So go ahead, create a 1.2 terabyte archival, our SC1 type here. That is our cold storage option here. That goes down to 2.5 cents per gigabyte per month. For that stuff, whoops, sorry, for that data that our business intelligence reports is querying, I'll go ahead and say I want a throughput optimized volume. I'm going to be scanning tables, so this can also be a hard drive here, where I don't need the random access quite as quickly here, and I can tolerate some latency. And this is just enough to hold the last few months here. So 2.5 cents, 4.5 cents per gigabyte per month there for that 400 gig volume. And now I take all that active stuff and I can make it as small as possible. Let's say it's only 20 gigabytes, but boy, if I did the math, 20 times 3, 60 IOPS, that's not going to be enough to serve my workload. So I can say, okay, instead I'm going to provision the I/O here. I'm going to provision at least 200 IOPS for this volume here. And so there's a slight added cost for that. But now I have doubled my storage, plus a little bit here. And I've gone from, remember that old solution was $80 a month? This is $63.50 a month. I've doubled my storage and yet saved on cost because I figured out how to be more intelligent about how I'm storing my data here. So this is just some of the benefits that you can see here when you don't have to be married to hardware that you've bought and have to try to get as much value out of there. Now, so far, we've just talked about all the nice and good stuff. There's a couple nightmares that if you're a storage admin that we haven't kind of broached yet. Security and recovery here. And just a couple of quotes. I've sanitized them from having any specific customer information here. One on encryption. We've been amassing data on our drives around this lab since the 70s. I don't know what's on them. I have no idea where half of them are. If one of them goes missing, it could be a non-event, or we could all end up in jail. It could be classified information. This is stuff that just is would terrify me if I had to sign off that yes, all of the data is secure, and yet I have researchers running around plugging drives in who knows where. And of course, the separate aspect is okay, all right. Second issue is backups here. And this I heard from a customer recently in the energy space. They had just broken the 1 petabyte mark on their research data here. And of course they're doing everything that they can to do the backups. They have a tape library here. They're taking tapes and going ahead and doing individual restore tests on the tapes. Because everyone in this audience, you should know that don't tell me about your last successful backup. Tell me about your last successful restore. If I've not tested my restoration capability, I probably don't have good backups here. They've run into a problem here of scale. They've hit 1 petabyte, and while they can do individual, single tape testing, they can't say, oh, yes, we went ahead, did a disaster recovery scenario, and have proven out that we can take, assuming that somebody put a bullet in our existing RAID server, we can go ahead, get all that data back and get back online within, let's say, 24 or 48 hours, whatever that recovery time objective is. They just can't afford to buy a 1 petabyte test bench here. So how do we try to address some of these concerns here? Well, let's go back to the security aspect here. And so we have our EC2 instance, our Elastic Block Store volume here. And what I can do on the security side is I can encrypt that. So I can use an encryption key and have that data stored securely at rest. And then when it's delivered to my compute node, to that EC2 instance, it's not decrypted at all. It's just transferred over the wire, encrypted, and the keys are delivered by something called the AWS Key Management Service, KMS here. And that is where it's actually decrypted. So now I can rest assured that all of the data being stored on AWS's EBS servers never can be decrypted here. It's only controlled by who has access to this key here, and only the instance can do that. This encryption is transparent to the operating system. As far as it's concerned, it's just a normal hard drive. It doesn't have to be aware that, oh, reading this block, I have to exchange the crypto data here for plain text by doing AES decryption, anything like that. Nothing you need to set up, just a checkbox in our console there, and you can get encryption going. As far as auditing all of this, it becomes very easy, because now all I have to do is see who has, who has access to those keys, and I can put policies on those keys. I can have audit policies in place there, where I can go ahead and see who has actually gone ahead and used this key. Is this key still active? If I've decided that, okay, I want to destroy all of my data irrevocably, I can just destroy that key. And now all I'm left with is just garbled data that nobody anywhere has the means to decrypt here. As far as the backups go, so we have a feature called snapshots. So I can take a point-in-time snapshot of this volume here and store it in an EBS snapshot. The back end of this is S3. You don't actually get to see this in S3, but we'll cover what the S3 service is here in a bit. So now I have a bit-for-bit copy of this volume here. And as far as what is actually stored there, for the first one, obviously I can't do an incremental. There's nothing to do an incremental backup of. So I have to copy the entire volume, but it is compressed there. So if it's a fresh volume, most likely I have a lot of empty space. All of that I won't be paying for. So it's compressed there. And then let's say that I want to do snapshots every 12 hours, so that the most data that I could lose if I accidentally start removing things or have some software bug in there that starts corrupting data, the most data I'll lose is 12 hours worth. So I can go ahead, set up features here to allow it to is this one going out? Testing. There we go. We'll see if this one's any better. So we can set things up so that we order perhaps all of our volumes to have snapshots every 12 hours here. This will be an incremental. So we only take the changed blocks here, again, compress those changes, and I'm only paying for those changed blocks. So I can keep on doing this as long as this volume lives. Now, ordinarily, if I were to take a tape library and destroy or erase that full backup, get rid of that first one, all of my incrementals have become meaningless. You don't have to worry about that with EBS snapshots. It knows what blocks it needs to keep. It knows what blocks it can throw away here. So none of that do you have to manage here, or does your backup software have to manage. Now, as far as when I go to restore this, all of these can be stored encrypted again. And so when I restore it, I go ahead, restore it, and I get another encrypted volume back here. And I can have now my live system and my test, if I'm testing my recoveries back here, I can go ahead, do a live test, do a comparison here, make sure that my restoration matches exactly, bit for bit, what my live system has here. And then when I'm done with it, I go ahead, get rid of it, and I stop paying for it. Suddenly, this becomes a much more tractable solution here as far as the cost. I can now do petabyte scale recovery tests on my existing budgets here. So if we just took those tools, EC2, Elastic Block Store, and snapshots, you could pretty much do everything that you do today on-prem. You could install whatever software you would like on that EC2 node. You can, if you wanted to do some kind of website, you can install Apache on it and serve web files out of there. But you've probably heard it a lot today, this idea of undifferentiated heavy lifting. I don't think anybody in this room is running an agency, a department whose mission is to run Apache web servers, for example. So if I wanted to make, let's say, shared storage here, have web accessible storage, again, there's the Apache solution here where I have to go in, I have to know Apache, how to configure the httpd.conf files. I want to have some monitoring in place, so if I'm on a shoestring budget, I'm probably going to be using Nagios. Auditing, oh boy, I haven't even thought about how to audit all this. If I had to go and report this to my CISO that, yes, we've locked everything down appropriately, it's a very manual exercise here. So this is one of the most common requests that we get. So we actually have a separate service to do just this. We have our simple storage service, S3, and also Glacier, which we'll get to in just a second here. So S3 is our first service that we launched back in 2006. And to store your data here in this web accessible format, what we call object stores here, you create buckets. And you can create up to 1,000 buckets in each of your accounts. And you decide, just like with EBS, whether these buckets should be encrypted at rest and in transit, or if they should be just stored plain here. Now, unlike EBS, where we're kind of attaching these virtual hard drives to servers here, this I can just serve out over the web. If this should be publicly accessible, if this is just a, for example, public outreach website, that top arrow there is what I would go to. That there's no encryption. I'm trying to get people to be able to view my content here, trying to share out. For example, maybe I'm doing outreach for veterans, let's say, and I don't need any dynamic data here. Just go ahead, serve that out there. On the other hand, maybe this is restricted data, but I don't know where my users are. They could be all over the web here. I can require them to have AWS accounts, and I can whitelist them. If it's all content that I need to serve out to a given site, I can close that down by IP address. You get your choice here. On the other hand, maybe I want this in my own private infrastructure within what we call a virtual private cloud in EC2. I can also say, oh, no, this bucket, this third bucket over here, that should be accessible only to my hosts within that VPC through what we call a VPC endpoint here. More things about S3 is that it offers 11 nines of durability. That's 99.9999999. If I got my nines correct there. As far as the durability of how often we will potentially lose an object. And it has an SLA, 99.99% uptime guarantee there. Pricing for this, so remember for EBS it was 10 cents per gigabyte per month for the general purpose 2 volumes. For S3, it starts at 2.3 cents, and that's for the standard, what we call standard storage there. If you have data that is infrequently accessed, S3 does also offer what we call an infrequently accessed tier, and that reduces the price there. It's 1.25 cents per gigabyte per month, and this is again in Virginia and Ohio. And it does have an additional 1 cent per gigabyte for retrievals there. But what if I have data, again, think about to the cold archive use case here, this data that I very rarely will read, that write mostly data there. I can put it into what we call Amazon Glacier, and Glacier offers extremely low prices here. So Glacier is 0.4 of a cent per gigabyte per month. Now you can't get the data back from Glacier immediately. There is a bit of a retrieval time, and you can choose whether I want the retrieval to be within 1 to 3 minutes, if I'm willing to wait 5 to 12 hours, pay a different retrieval rate there. So, but it's perfect for that data that you expect to hardly ever, if ever, access there. Another nice feature is that I don't necessarily have to do anything to move my data from S3, from this hot online storage here, all the way to this cold storage of Glacier. We have what we call lifecycle policies that I can set up, let's say, after 30 days after it's written, move it to the infrequently accessed tier. 90 days after it was written, to Glacier, and then a year later, go ahead and delete it. And you can decide if you want to keep it around, you can skip the deletion step there. So one of the most powerful uses that we're starting to see with S3 is as a data lake. So for those who are kind of new to this term of data lake, it's typically you store data in its native form. So I don't try to renormalize it, put it in, let's say, a relational database. I don't try to make everything look like HDF5 or JSON or whatever. It's kind of an acknowledgement that we're dealing with so many different data domains, and that the data is potentially very messy here. And I don't want to try to corrupt it here. I don't have a single way that I'm accessing this data either. I have users coming in with all kinds of different tools here, and as a storage administrator, I just say, okay, I give up. I will provide you storage, and we'll figure out how to get the data to you just in time so that you can do something with it. And that's what we're looking at with a data lake here. So, okay, S3, great for storing things, but the first thing that we need to do is we need to get the data into S3. If you are in the cloud entirely, Kinesis, we have a new in the last year or so, Kinesis Firehose is a great way to hook S3 up to an ingestion pipeline. If I'm getting data from sensors, IoT, maybe I'm getting readings from all over the world, that type of stuff, I can use Kinesis for that. On the other hand, if I'm moving things from on-premises, I probably want to look at something like Direct Connect. Direct Connect allows me to have a private line to AWS up to 10 gigabits per second there, just stream the data in. Sometimes instead, I have too much data, transferring it over a network is going to take forever, and it's only a one-time use thing. We also have something called Snowball, where I can go ahead and get these 100 terabyte devices that are shipped to me, fill them up with data, just go ahead, wrap them up, send them back. And if you saw our reInvent announcement, we have a new product in that line called Snowmobile, which is a semi-truck full of drives and associated equipment. Can store up to 100 petabytes here, and this is how Digital Globe ingested all of their data for their new GDBX platform here. They used the snowmobile there. So once you've gotten it into S3, your expert users are going to say, okay, let's start figuring out how we can use this. And so on our analytics side, the first thing they're probably going to play with, the first two services are Athena and QuickSight. Athena allows you to perform SQL queries against non-SQL data. So if it's JSON or CSV or any of the formats that it's built on a related open source product, Apache Parquet here. If Apache Parquet can parse it, you can go ahead, write a SQL query against it and very quickly start getting answers here. I don't have to spin up any infrastructure, just write SQL. It somehow magically talks to S3, gets the data out. If I want to see graphs of this data, QuickSight is going to be my go-to platform here, where I can go ahead, start plotting things from this data here, and then have other additional services here. If you are familiar with Hadoop, we have our EMR, Elastic MapReduce service here. Redshift Spectrum is our data warehousing platform. The Spectrum feature of Redshift Spectrum allows you to do the queries directly against S3, announced a few months ago. Once I've, want to go beyond the expert users, they figured out how people want to go ahead and use this data. Okay, I have to start figuring out how am I going to enable people to search it. I have to have some what we often call curation solution here. I have data, let's say, doing weather analysis. I have data and I want to find what the temperatures in Washington, D.C. were from 2 years ago. Well, if I know SQL, I could go and do that, but my end user is probably not going to know that. So I have to have some way of cataloging this. And DynamoDB is our NoSQL database here. It's a very popular way of going ahead and analyzing all of the, or storing all of the different analytics associated with a given data set here. So you can use that as a metadata store. I have customers also using Elasticsearch, which is you typically associate with like text searches, but you can also do parameter searches and have metadata documents stored in there. Okay, once I've gotten that searchability piece in there, I can go ahead and start building my user interfaces. So you may be leveraging Lambda plus API gateway to create some kind of nice user interface into this data. I can use Cognito if I don't know who my users are necessarily going to be. They're going to be on mobile platforms, let's say, but I have to have some semblance of identity there. I can go ahead and use Cognito. And of course, underpinning all of this, it has to be secure. It has to be reliable. I need to have tools that are telling me that all of this is working. So underpinning all of this, we'll go ahead and use our identity and access management to make sure that data that is restricted cannot be served out, cannot be accidentally analyzed here. CloudWatch to make sure that everything is performing as I expect. I don't want queries taking hours if I expect them to take seconds, for example. CloudTrail will go ahead and log all of the API calls so I can go in and do analytics like, oh, I see some anomalous access patterns here. Maybe I should do something about that. This is not a security session. That's over in Salon C. But this is kind of that entire ecosystem here. Now, don't get overwhelmed by this picture. This is a picture showing what all is possible here. If you just want to get started, all you really need are, you can start with S3 plus Athena or QuickSight here. Quite often, I find myself having to analyze a few dozen gigabytes of data. And this is all I need. Somebody has tossed me a bunch of files. I go ahead, do the analysis here, get them the results, and poof, I'm done here. So you don't need, this is my own little personal data lake here. Don't feel overwhelmed that you need to know all of these different services here. In addition to AWS-specific services, we do have partners who are already doing things like this, like Tableau. And if your business intelligence folks are more comfortable using Tableau, Tableau knows how to talk to a lot of these products here. It certainly knows how to get things from S3. For your security folks, Splunk. They're probably already using S3 as a data lake and not even knowing it through Splunk here. So for the vast majority of customers, just using S3 in a single region, like our Virginia region, is more than adequate. But there are some departments, some agencies who are tasked with thinking about big disastrous events. Like what if Hurricane Sandy a few years back, what if that was even worse and it had interrupted all telecommunications up and down the eastern seaboard? Well, for that, I want to, the continuity of operations, being able to get the government back up and running is going to be critical. So if you are worried about this, we do offer solutions for cross-region replication here. So I can, as I'm writing data out to the Virginia region, I can tell it to automatically replicate over to our Oregon region. So now I have geographic dispersity on the East Coast and West Coast here. I can now also use that Oregon data as a read replica. So if I need to be able to serve data out and I'm worried about latency, I can go ahead and say, okay, if you are closer to the Oregon region, go ahead, read it directly out of there. If you are potentially worried about some sort of security breach here, you can actually write it into a different account, an account that I don't control. So now I can say, oh yes, I'm writing all of this data, but if I get hacked, if I have, if I've for some reason not followed all the best security practices and somebody comes in, erases all of my data here, and normally that'd be, okay, well, it's gone. Well, now I have a story that I've transferred it to another party who maintains control. And so I can demonstrate that to an auditor that, yes, the backups are being made, this is being replicated out, and I can't touch this. So if somebody in my org goes rogue or, I, again, haven't followed the best practices for some reason, there is a fallback here. So we've talked a lot about web accessible storage. I come from a background where researchers are still running codes from like the 70s, 80s in some cases, predates the web, let alone AWS. So they do a lot with shared file systems, so networked file systems here, NFS type of stuff. And again, you can do this on EC2. You can go ahead, set up your exports file, export this file system within your VPC here. Again, the auditability leaves a little bit to be desired here. Most people are not in the business of running NFS as a service. So we do offer something called the Elastic File System here. I can go ahead, say, yes, create an NFS volume here. I don't have to worry about the replication. It's already being replicated on the back end here. I get a mount point that I can go ahead, mount on my different EC2 instances here, and also on premises. I can, if I have a direct connect back to my on-prem servers here, I can go ahead and use that as a data store there. So if you are still in the stage where you have code that needs to write a file over here, needs to read it back over here, certainly consider EFS or Elastic File System as an option for solving that kind of use case there without having to spin up and maintain all of your own infrastructure here. As far as folks who are using this, Atlassian is using it for Jira, for their Jira Cloud to cut costs and accelerate performance. Monsanto is using it for geospatial type of data there. So we do have people who are actually using this. It's not theoretical. It's stuff that you can pick up and use today. If you are earlier on that adoption framework, hey, I still need all of my compute on-prem for whatever reason. It's going to be a couple years before we start moving that out into the cloud. But boy, I'm having storage woes on-prem here. We do have options for that, where you can leverage the storage options we have in the cloud and bring it back on premises. So we have what we call Storage Gateway here, which is a virtual appliance that you can run in either VMware or Hyper-V, and run it on your own server there. And now you can, there's a few different use cases here. The first one is, okay, I have a disk, and I just want to make sure there's an offsite backup, bit-for-bit backup available in the cloud here. And so EFS has an option called volume gateway storage mode, so it's just replicating every write here. It just replicates that up into EBS here. On the other hand, maybe I need to expand my storage. Okay, I have a 1 terabyte disk here, but boy, most of that data I hardly ever touch. I want to use this as a cache of whatever is in the cloud here. So you can use the gateway cached mode here. And that can go up to 32 terabytes per volume here. I can go down to as little as 1 terabyte, possibly even less on premises as far as what I'm caching here. And now this will intelligently pull down what it thinks is going to be accessed next, make sure that that the cache is warm for all the applications that are accessing the data. But once it goes cold, it goes ahead, puts it back out into S3, and you don't have to worry about building out your on-premises infrastructure. I do have some customers who are trying to figure out what to do with their tape libraries. Tape libraries are great until things go wrong or you have to upgrade them. Upgrading is especially a pain because often you have to run both the old solution and new solution, so you have to find room for 2 tape libraries in your on-prem systems here. So you can operate it in what we call tape gateway mode, and it creates what are called virtual tape libraries here, and you can put them on virtual tape shelves, go ahead and store those into Glacier there. One of the new releases of Storage Gateway, so all of these are more akin to like iSCSI volumes where I get blocks, so a virtual hard drive that I then have to share out myself. One of the recent releases is what we call the file gateway mode, where I have, instead of volume views, the iSCSI blocks here, I'm actually looking at individual files here. And I can use what we call the file gateway, where it's grabbing S3 objects natively. I can get a view from S3 here of everything that was stored in S3 as a file, without having to rewrite all of my software that stuff from the 70s that isn't even aware of what the web is, and I can go ahead and start running it again. So a little bit about databases. This is not a database talk. We have plenty of database talks here, but I'd feel remiss if I didn't kind of cover this to some extent, because sometimes when you're thinking about storage, all you think about is storage. Like a DBA comes to you and says, hey, I'm running Oracle and I need a system with 30 terabytes of storage here. I hear 30 terabytes of storage. Well, hey, wait a minute. What about the rest of that system there? So again, you can run Oracle, or in this case, I have a MariaDB here as my example. I can go ahead, spin up an EC2 instance, have an OS drive where I install MariaDB, have a separate data volume, probably multiple data volumes where I'm storing all of my data there, bring my schema, go ahead and install it. And then when it comes time to do backups, yes, we put all the tools that we were talked about earlier, put those together, create the snapshots for my backups. And now when it comes time to, there's a new vulnerability in MariaDB, or there's performance enhancements, I have to go in and maintain that head in there. Well, most of this is not core to my mission, except for the schema and data. This is, again, what we call that undifferentiated heavy lifting. Everyone is running databases today. And there's no mystery how to do it. Boy, Amazon, can you help me out here? And for this, we do have our RDS service. You still go in and specify how much storage you need here. You can specify other aspects of it, but then leave it hands off. So don't, again, in the start of this, we kind of gave you tools, that fallback of EBS for if I can't do it anywhere else, I can always do it in EC2 and our Elastic Block Store service. But again, look into other options where we get rid of the stuff that you don't want to have to run here. You can go ahead and use, in this case, our relational database service, Amazon RDS. We'll go ahead and take care of this for you. So one final piece that we haven't quite covered yet is caching. So quite often when we're trying to speed things up, we'll keep things in a results cache, or sometimes despite all of our best efforts here, optimizing, we've gone and optimized our database, we've put everything that we can on provisioned IO volumes here, and done everything we can, and yet our database is still under load. It's going up in flames. It's just falling further and further behind with each query it gets here. What can you do in this case? So we do have instance types with what we call ephemeral storage or instance storage attached to it. So these are high-speed SSDs that are attached directly to that node. No network cables involved here. You can, with our i3 16 extra large instance types, those were released just a few months ago, you can get up to 15 terabytes of local SSDs here. You can go up into hundreds of thousands of IOPS just serving all of this data here. Now, one thing I want to call out here, we use the term ephemeral. These are ephemeral stores. If that instance goes down, whether you say stop or terminate, or there's a hardware failure and we have to retire that instance, that data is going to go away. So you don't want to use this as your sole source of precious data here. You want to truly use it as a cache that you can't do anything else with. Go ahead, mirror it off the host, but serve all your reads off of it. And then the other thing to keep in mind is that we've talked a lot about hard drives, SSDs in the cloud. RAM can also be storage too. There are databases like SAP HANA and Aerospike that use RAM as their storage here. So for these, we have, I would take my instances here, you provision as much memory as I can here. And so we do have high memory instance types. Today, you can get up to 2 terabytes of memory on what we call our X1 series here. We've also announced that later this year, we plan on having 4 terabyte instances with a roadmap for 8 and 16 terabytes, again, of memory, of RAM here, not drives, for these high workloads that need that instantaneous store there. So that kind of is starting to wrap up all of the different options here. There are places where you can go to learn more here. This is more intended for if you want to download these slides off our website here. Places that you can go to learn more about these different options here. Our document, we have oodles of documentation there. Discussion forums, people they're discussing their different use cases here. The AWS blog, Jeff Barr kind of leads that effort. He often posts all the new features and new use cases that people are doing with storage and databases, caching, et cetera there. So go ahead, peruse these. And with that, we are pretty much out of time. So thank you very much. Have a great summit, everyone.